How do you find the particular solution to a separable differential equation? When we talk about finding the particular solution, this means to find the specific solution that satisfies a given initial condition. So let's look at an example to see what I mean by that. Let's say we have the differential equation dy dx is equal to x times y, and that our initial condition states that y of 0 is equal to 4. So we'll come back to this piece of information later. The first thing we have to do is to find a general solution to this equation, which requires separating variables. So to do that, we need to get all the y's on one side and all the x's on the other side. So we can divide both sides by y, multiply both sides by dx. This will give us dy over y equals x dx. Now you can see that our variables are separated, with the y's on the left side and the x's on the right. This allows us to now integrate both sides to remove the two differentials so that we can get an equation with y in terms of x. By integrating, we have the integral of 1 over y, which is the natural log of y, and that'll equal the integral of x, which is x squared over 2, and remember to add your plus c on the side with your x variables. Now, to get the general solution, we need an equation with y in terms of x. So we need to eliminate this natural log function here to extract out that y variable. To do, we'll take both sides to the power of e. This will eliminate that natural log, leaving us with our general solution of y equals e to the x squared over 2 plus c. We can also rewrite this expression right here. Although this is a correct solution, we can rewrite it in a slightly simpler format if we consider another way to rewrite this side of the equation. We can rewrite that side of the equation as e to the x squared over 2 times e to the c. And we know that e to the c, this term, is just a constant because e is a constant and c is a constant. So we can just write this as c e to the x squared over 2. And I will rewrite this one more time. Right here, our final answer, we'll do it in black, for our general solution is y equals c e to the x squared over 2. And you can see that this will allow us to find our particular solution in a slightly easier way. So this is the way we want to write our general solution. Okay, so now let's make a little bit of room. And to find our particular solution, essentially what we need to do is apply our initial condition in order to find the value of c. The particular solution will have the value of c that satisfies our given initial condition. So let's plug in our variables or our values for y and x that are given in our initial condition. As you can see, x equals 0 and y equals 4. So we'll apply those into our general formula here. Y is 4. We can say that equals c, which we're solving for, times e raised to the 0 over 2. 0 over 2 is 0, and e to the 0th power is 1. So we're left with c equals 4. Now that we have c, all we have to do is just plug it in over here. So we can just erase our c and put in our 4, and this gives us a nice little particular solution to this differential equation. Okay, let's hop right into our next example here. We'll do dy dx is equal to 2x plus 4. So for this one, we can't immediately separate variables because we have an addition sign between these two terms on the right. So in order to get rid of that problem, we have to factor out a 2 from the right side. That'll leave us with 2 times the quantity x plus 2. Now we can separate variables as we got rid of that addition sign. So we want to put the x's with the dx, and in this case, we're going to put the 2 with the y, the dy differential. So we'll go ahead and divide by 2 on both sides, and we'll multiply the dx to the right. So we'll get dy over 2 equals the quantity x plus 2 times dx. Now we can integrate, as we separated the y variables to the left and the x's to the right. So we'll integrate both sides, and essentially on the left side, we're just taking the integral of dy, because the 1/2 comes out as a constant, and the integral of dy is just y. And so we'll have, if we bring back in the constant, we'll have y over 2 as the integral here. And then on the right, this will just equal x squared over 2 plus 2x. And we'll add our plus c on the end. Okay, let's clear this out and make some room. All right. So now we need to isolate the y variable to find our general solution. And I realized I actually forgot to give the initial condition for this problem, so I'll just write that in the upper right corner. We're going to say our initial condition is y of 0 equals 5, and that will be useful in a minute once we find our general solution. Okay, so now we need to isolate y, and so we can do that by multiplying by 2 on both sides. That'll give us y equals x squared plus 4x plus c. That's our general solution to this equation, now that we have y in terms of x, and we still have the c variable here that we now need to get rid of and find a value for, given the specific initial condition. So let's go ahead and do that. We know that y of 0 is 5, so we can say that y is equal to 5. And then we know that the x variables are 0, which is great for us because it works out really nicely. We don't have to deal with any of these quadratics or anything like that. And so it's just going to be 0 plus c. Just ignore those, goes to 0. And we have c equals 5. And so you can see that worked out really nicely. We have our c, and now we can write our particular solution from our original general solution now that we have this value of c. So we'll take this original general solution and just plug in this c value that we just got. Okay, so it's going to be y is equal to x squared plus 4x, and now instead of c, we put in 5. And that right there is our particular solution to this differential equation, given the specific initial condition of y of 0 equals 5. All right, moving on to our last example here. We'll up the difficulty just a little bit. Won't be too bad though. Again, we'll say that dy dx is equal to, and now we'll have 4y squared over x cubed. And I won't forget the initial condition this time. It's y of 1 is equal to 3. And so we'll get to that initial condition once we find the general solution. And so to start here, just to make it a little easier to see how to separate variables, I'm going to start by cross-multiplying on both sides. And so we'll get x cubed by taking this x cubed and bringing it to the upper left. By cross-multiplying, we'll do x cubed dy is equal to this pair right here, cross-multiplying those, we'll get 4y squared dx. And so you may be confused because this isn't separating variables. These are all mixed up variables, and this is wrong. We don't want to do this, but it just makes it easier to see how to separate the variables from this point compared to the original point, where they're all kind of in a weird orientation. So now you can easily see that we have to bring this x squared over here by dividing both sides by x squared, and then we can also divide both sides by 4y squared, bringing the 4y squared over to the dy side. So we'll go ahead and do that, leaving us with dy over 4y squared equals dx over x cubed. So now what we can do, now that we have the y's on the left and the x's separated to the right, we can integrate. We'll go ahead and integrate, and we can say that the integral of 1 over 4y squared, we know that that is equal to, we know that we can take the 1/4 out as a constant, and then the integral of 1 over y squared is negative 1 over y. And so we can say that the integral of this left side expression is negative 1 over 4y. And then on the right, what's the integral of x to the negative 3? We can can say that is x to the negative 2 over negative 2, which is negative 1 over 2x squared. And so we can write that right here. And remember to add your plus c. Okay, and then we can erase this little power rule on this right side. Okay, so now why don't we make a little room by erasing this previous work. Okay, now we have to isolate this y in order to find our general solution to this equation. So first, I think maybe we should just cancel out these negative signs on both sides. That'll make it really nice for us. So no negatives to deal with here, which is good. And then we can multiply both sides by 4 to get rid of this 4 in the denominator of the y expression. Okay, so that's our first step here to isolate y. So then we'll be left with 1 over y is equal to 4 over 2x squared. And we'll again just have plus c over here. Remember not to put a 4 in front of the c. That doesn't mean anything. The c absorbs that extra 4, so there's no need to add that in. Okay, now we have to simplify this right side of the equation first, and then we can flip this y expression after that. So we'll again have 1 over y is equal to, and then this 4 over 2 is going to simplify. There'll just be a 1 on the bottom and a 2 on the top, and that'll leave us with x squared on the bottom, and then again plus c. So now, I think we're good with this bottom expression now, so I can erase that. Now we have to flip this entire expression because the y is in the denominator on the left side, and we want that just as y, not 1 over y on the left. So we need to take the reciprocal of this entire expression, so that's essentially taking everything to the power of negative 1. So we'll have y on the left, and now we can just put 1 over this entire quantity that's on the right side. So 2 over x squared. So we're going to have like a complex fraction here, but that's okay. 2 over x squared, and then just plus c. So just taking this entire right side expression and just doing 1 over what's circled in green here. Okay, so now this is the general solution. We have the general solution to this equation. We have y in terms of x with plus c. And so now we have to find the value of c given our specific initial condition, y of 1 equals 3. And so let's go ahead and do that. Just draw a little arrow up here to the side. No, we don't even need that arrow. I think it's pretty obvious. We're going over here. Okay, so we know that this 3 here will equal y. So 3 is equal to 1 over, we know that x is equal to 1. So we can do 2 over 1 squared, which is just 1, plus c. And then we have 3 equals 1 over 2 plus c after we simplify. And then going on the bottom here, we can multiply both sides by 2 over c. And that'll leave us with 3 times the quantity 2 plus c. So we'll have to distribute is equal to 1. And then 6 plus 3c equals 1. And I'll erase up here so we have more room. And so solving for c now, if we subtract 6 from both sides, we'll be left with 3c is equal to negative 5. And then dividing by 3, c equals negative 5/3. And so that's our value for c. And now we can write our final particular solution to this equation. I got to figure out where to write it here. Let's get rid of our initial condition there. And I can just write the particular solution, our final answer to this last problem, right up top here. It's going to be y equals 1 over 2 over x squared minus 5/3, which is a value of c that we just found from the initial condition. And that is our final solution to this third problem. And just a note, you can easily simplify this expression on the bottom if you wish, and get rid of that complex fraction. It's not necessary, but you can do it if you like to see it a little bit in a simpler form, not so messy. But that's up to you. That's it for this video. Thanks so much for watching.